In question 2, in the first question, we have to use Demoff's theorem. Demoff's theorem basically says that if you can write a complex number in this form, r cos theta plus I sin theta, z to the power n will be r to the power n times cos n theta plus I sin n theta. Now this expression on the top can be represented as 1 cos theta plus I sin theta to the power 4. This is just saying it's z to the power 4. If this expression inside is z, this is z to the power 4. Using Demoff's theorem, I can write it as cos 4 theta plus I sin 4 theta. And we have 1 to the power 4 in front, but that doesn't change anything. So the numerator can be written as cos 20 pi by 12 plus I sin 20 pi by 12. The 20 comes here from multiplying 4 over here. So this is how we work with the numerator, and we can do the same with the denominator as well. We just have to make sure that this minus sign is changed. So I can do that by using this identity over here. So sine of theta, or sine of minus theta, is equal to minus sine theta. So I'll use the opposite one over here. So sine minus sine theta is sine minus theta, whereas cos theta and cos minus theta are the same thing. So this is cos minus pi by 3 minus I sine minus pi by 3. Basically, if I add a minus over here inside the sign, I'll also add a minus here. So the two minuses over here combines to make a plus. So I get plus I sine minus pi by 3. And then we raise this to the power of 3. So we get this expression. So now we get cos 3 into minus pi by 3 plus I sine 3 into minus pi by 3. I just get cos minus pi plus I sine minus pi. Since we know the exact value of cos minus pi and sine minus pi, we can just calculate this. Cos minus pi is minus 1, whereas sine minus pi is 0. So we have I times 0. This is just minus 1. So the whole expression can be written like this: cos 20 by 12 pi plus I sine 20 by 12 pi divided by minus 1. So over here we get minus cos 20 by 12 pi minus I sine 20 by 12 pi. Now I want to convert this into cos 2 pi by 3. So if I notice over here, we have this rule: cos theta minus pi is the same as minus cos theta. So this can be written as cos 20 by 12 pi minus pi. You have a minus here and a minus from this, so this becomes a plus. And for sine 20 by 12, we can do the same thing. The same identity holds. So sine theta minus pi is the same as minus sine theta. So I can do the same for this. I get plus I sine 20 by 12 pi minus pi. Basically, I get a minus from before and a new minus. This becomes a plus. So finally I get cos 2 pi by 3 plus I sine 2 pi by 3. Another way to have done this problem is, instead of calculating this minus 1, I could have kept it in this form. I'll do this down below. This is the other way. Instead of this, you can do this. So now we'll divide complex numbers in their polar form, and if you do this, this 1 and 1, these are the magnitudes. So r cos theta plus I sine theta. I have r1 cos theta plus I sine theta divided by r2 cos x plus I sine x, something else. If I do this, the result would be r1 by r2 times cos theta minus x plus I sine theta minus x. So this would have been cos 20 by 12 pi plus pi plus I sine 20 by 12 pi plus pi. This would have been cos 8 pi by 3 plus I sine 8 pi by 3. And now we know that cos 2 pi by 3 is equal to cos 8 pi by 3, and sine 2 pi by 3 is equal to sine 8 pi by 3. And then you could have written it in this form. Now for part B, we have to shed on a Gantt diagram these two graphs over here, z minus z1 modulus less than 1 and this one here. I'll do one in red and one in blue. So for the red one, anything in this form, z minus z1 equals to r, is a circle with center z1 and radius r. And anything in this form, so arg z minus z1 equals to an angle theta, it will be a half line starting at z1 and pointing at theta degree to the horizontal. So this is the horizontal, this is theta. It's not just the horizontal, it's the positive real axis. Now at first I want to find where z1 is. Cos 2 pi by 3 is minus half, and sine 2 pi by 3 is root 3 by 2. So minus half root 3 by 2 is the starting point. So I'll draw my axis over here. This is the imaginary axis, this is the real axis. I want to go minus half in the real axis and root 3 by 2 in the imaginary axis. Now since the radius is 1 and root 3 by 2 is less than 1 and so is half, I just care about the magnitudes. Both of them are less than 1, so the circle will intersect both the x and y axis. So the circle something like this. This is the center. And then the half lines should be added. Let me color this first. Okay. And now for this, 3 pi by 4 is 134 degrees. 90 degrees is half pi. 3 by 4 is 0.75. So it's at this angle over here. So for 0, we have the horizontal axis itself. And for 3 pi by 4, we have this. So we'll plot this. This angle over here is 3 pi by 4. And now for the shaded area, I want to shade inside the circle because this is less than. So I want anything less than the radius. So it's everything inside the circle. And for this, I want the angle to be between 3 pi by 4 and 0. So I can be anywhere in between. So these are the possible places I can be. So for the second equation, the shaded area will be this blue region. And if we combine the shaded regions, red and blue, we find that the common intersection is this inside the circle. So I'll shade this now, remove the other ones. This is the shaded area. Now for part C, we have to find the smallest possible argument z, which is in the region or the shaded region. So I want to minimize the argument for it. The argument is the angle from the positive real axis up to the point. So if I look over here, this point over here will have the lowest angle because we start measuring the angle from here and go like this. So this angle would be the minimum, and I want to find which point this is. But as we notice, this point is at an imaginary value of root 3 by 2. We just need to find the real axis value, and we can do that easily as well. We know that this part is the radius, which is 1, and I know that this point over here, the center of the circle, is minus half comma root 3 by 2. So this point will have an x coordinate, or the real axis value would be minus half plus the radius, which is 1. So this is half. So I know the x and y coordinates. I can easily find the angle. I have this triangle over here, this right triangle. The height is root 3 by 2. The base is half. I want to find this angle theta over here. I can use tan theta equals to opposite by adjacent. The opposite is root 3 over 2 and the adjacent is 1 over 2. So tan theta equals to root 3, and theta would be tan inverse root 3, which would be pi by 3. And this is the answer to part C, and that's it for question 2.